In the future, by the year 2050, it is expected that there will be a city on Mars, marking humanity's first step away from the protection of Earth. But establishing a colony on Mars is not as simple as launching a rocket. This is a challenge that will push us to think about how to survive on a planet that has almost no natural resources. One of the biggest differences between a city on Mars and lunar bases is the need to be completely self-sustaining. According to experts, relying on Earth for daily needs is impossible because the round trip takes more than 8 months, far longer than the roughly one-day trip to the moon. That's why the citizens of Mars need to learn how to extract and transform the limited resources available on the planet. Water from ice, minerals from the soil, and air that's almost pure carbon dioxide. To ensure life can flourish, robotics and AI will be the primary tools even before humans arrive. Humanoid robots like Optimus can perform construction, maintenance, and other critical tasks in the harsh environment of Mars. It is said that these robots will serve as trainers and builders, gradually preparing the way for the first colonizers. But the environment on Mars is extremely dangerous. The temperature is even lower than the coldest on Earth. In Antarctica, the air is drier than the Sahara Desert, and there is almost no atmospheric pressure to keep liquids stable. This means that a person who steps out of their suit would immediately freeze, boil, and lose all the oxygen in their body. In addition, there is high exposure to radiation from the sun because of Mars's thin atmosphere. According to SpaceX's report, the first mission to Mars could begin in 2026 using 5 starships each. The goal is not just to arrive, but to start building infrastructure for a larger population that could reach over 1 million people, a step towards becoming a truly multiplanetary species. Overall, the city on Mars is a symbol of humanity's ambition and technological innovation, a project that will teach us how to succeed despite limited resources and extreme risks while shaping our future. On the first journey to Mars, the main goal is to land even just 1 starship safely, a mission full of learning and challenges. That's why SpaceX plans to send more than 1 vehicle at the same time, because they expect there will still be a learning curve. According to analysts, it's common for SpaceX to experience failures or minor explosions at first, but once they get the right method, they can repeat and implement it consistently. Even if a starship lands successfully and deploys some Optimus robots on the Martian landscape, what they can do will still be limited until the next wave arrives. 2 years after the first successful landing, the first true colonial fleet will arrive. 20 Starship landers, each carrying 75 tons of cargo, most of which is for the infrastructure needed by the first humans who will arrive. As for the location of this colony, the space station chose the Arcadia region as the primary candidate. It is located to the northeast of Olympus Mons, the tallest mountain in the entire solar system. Arcadia is flat and close to the equator, but it has large deposits of water ice, the most important resource on Mars for many reasons. One of the 2 main projects of the Optimus bots is the water treatment plant. Humans need clean water, but it's very heavy to bring from Earth, especially on an 8-month journey. That's why a large portion of the water needs to be recycled. But there is a limit to using recycled water. You can't turn last night's urine into coffee without replacing what's lost. Aside from hydration, water can also be separated into oxygen and hydrogen. Through this process, robots can also produce oxygen for the colonists to breathe and hydrogen for making rocket fuel. The second major project is the rocket fuel production plant. Although pure hydrogen could have been used, it's complicated because that element is very light and reactive. That's why SpaceX chose methane, which is hydrogen mixed with carbon. 1 carbon atom for every 4 hydrogen atoms, to make it more stable and easier to handle. While hydrogen comes from water, carbon will be taken from the thin Martian atmosphere, which is almost pure carbon dioxide, using carbon capture devices. In this way, The first robots will lay the foundation of life on Mars, from water and air to fuel, even before the first humans arrive. Aside from producing methane and extra oxygen for humans, Mars will also need a mining operation to support the new robotic manufacturing industry. The water ice needed is underground, so it has to be dug up. It's not surprising that SpaceX will have access to some boring technology from another sister company, although a full-scale tunneling machine is not included. It's not practical for the initial construction. The same design, scaled down to a Martian mining rig, will begin to unlock the resources needed for human survival and for building a sustainable colony. As a bonus, all the soil and rock that will be excavated can also be processed into an asphalt-like material, which can be used for making roads and landing pads. This is the situation 2 years after the first major robot landing. This could possibly happen in the year 2030. Now it's time for the first human to arrive on Mars. As part of the large Starship fleet, there are 100 landers, each carrying 150 tons of cargo. When the people arrive, there are 2 new construction projects that need to be started. The first is the power plant. Until now, a small amount of electricity has been enough for the robots to recharge using a few solar panels. But now that the people are here, the energy demand is now higher. Once the plant is ready, all the infrastructure built by the robots will be activated. Life support systems that provide oxygen, water, heat, and air pressure need to run 24/7. A day on Mars is almost the same length as on Earth, so every 12 hours, it will get dark. This means that the solar panels need to be hooked up to large batteries. It's no surprise that Tesla has already made large battery storage systems, and systems they call megapacks can also be placed inside the Starship lander. Just 1 megapack can power a small town for several hours, enough to keep a small colony running at night. But people also need homes on Mars. The large Starship lander provides temporary shelter for the first settlers. However, it's not ideal for long-term housing because of its height and thickness. An elevator is needed every time you go in and out. That's why now people and Optimus bots are working together to build the first permanent habitat on Mars, a step towards real life on the red planet. The first homes on Mars can come in different forms. Many people immediately think of a large glass dome, but for the first Martian homestead, this would be very difficult. For example, on Earth, we rarely see large glass domes. The closest example is the Singapore Airport Nature Dome, which has 135,000 square meters of internal space and weighs 3,500 tons. To build a dome like this, it would require at least 350 Starship loads of materials and additional construction machinery on Mars. Instead of glass, we can use materials naturally found on Mars. One idea is the ice dome, which is currently being studied by NASA Langley Research Center. This takes advantage of the insulating properties of water, similar to the igloos made by the Inuit in the north. The frozen water will retain heat and, most importantly, protect against radiation from the sun. The ice dome starts with an inflatable donut-shaped module at the base. Then, a solid mold is built around it, and autonomous robots will fill the dome with water ice from the Martian surface. Ice is translucent, so natural light can enter, which helps with the sleep cycle and mental health of the people inside. Although the ice dome is excellent as a home, it is limited when it comes to larger facilities, like research labs and factories. That's why we can keep the inflatable module at the core, which we can make on Earth in any shape or size, and then use a stronger material on the outside for the solid shell. This is where local resources come in. As ice mining operations continue, a lot of rocks will be excavated, and these can be used as construction material. For the strong shell around the inflatable house, we need a concrete-like binder. This binder can also come from human waste. This is a concept called Astrocrete or Biocrete. In this process, the bodily fluids of astronauts become building material. According to a study by the University of Manchester, they have already tested this process using human blood, sweat, and urine. In an ideal Mars colony, we will try not to use too much blood and sweat, but urine will be a sufficient supply. We know that drinkable water can also be obtained from this, and the remaining waste product can still be used in building homes. This substance is called urea, and this is the good part. It can be mixed with Martian soil to make concrete that is stronger than what we make on Earth today. Even though it seems strange, during medieval times, stonemasons used animal blood in their mortar to make castles stronger. So this isn't completely new. Next is food, perhaps one of the most difficult and most important aspects of a self-sustaining city on Mars. Just like water and fuel, the amount of food we can bring from Earth is limited. It's not enough to just bring canned goods or dehydrated meals. Eventually, we need a sufficient and continuous supply of food produced right on Mars for 1 million people or more. This is not just simple farming. This is a test of technology, science, and the capability of humanity. Farming is already difficult even on Earth. Just imagine doing it on Mars. Martian soil is literally toxic. It contains what are called perchlorates, a type of chemical that contains chlorine, which is used in swimming pools to prevent bacteria. On Mars, the same chemical prevents anything planted in the soil from growing. That means traditional farming as we know it on Earth just won't work. Advanced techniques and Mars-specific solutions are needed to keep any plant alive. There are two main solutions, both full of challenges. First, we could bring Earth soil for agriculture. But even an entire starship full of soil wouldn't be enough for the needs of 1 million people. The weight, volume, and logistics are extremely difficult. A single starship can only carry so much. We need thousands of tons of soil, but we need hundreds of thousands of tons. Second, we can also build a Mars-based industry to process Martian soil. We need to remove the perchlorates and add enough nutrients to make the soil viable for planting. This means there will be a new industry, a soil processing system that will remove toxins, restore fertility, and ensure that plants can grow. Think of it as a high-tech greenhouse operation. But because the environment on Mars is so harsh, robotics, automation, and scientific monitoring are needed so that every plant can survive. There's another creative way to ensure sustainable food production: repurposing human waste. If urine can be used to make cement and help with construction, number 2 can also be used as fertilizer to feed 1 million people. Yes, it's not a pleasant sight and it's a bit unusual for many people, but it's a practical solution. In this way, all biological waste becomes part of a closed-loop system where nothing is wasted and every drop has a purpose. When we secure the basic needs, electricity, water, oxygen, shelter, and food, and we can do this in a self-sustaining way that doesn't rely on Earth, this is the first real step for humanity to become a multi-planet species. Every plant that grows in Martian soil, every bit of food produced from local resources, is a symbol of our capability and determination, living proof that we can thrive in a world that once seemed uninhabitable.